So I'm on this data analysis bent at this moment. Um, and, I was thinking about every time that you try to use some form of data analysis, there's a whole bunch of tools that you can use or predictive models. Most of the time we use regression models. That's a key tool, right? It's called the workhorse of science. And these regression models are very, very inadequate. Uh, and no matter how in the sort of challenge, you get this balance, right? The more sort of nuance that you actually use, the less likely people are to actually understand this thing, right? With the regression models, and the more simpler you have, the 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 less it actually applies to the real world. Now, I am very much in favor of using very simple models and simple regression models, simply because it's easier to explain. Now, the trouble is that these models that we have, when you actually use them, they don't predict reality. Real life is not as linear and sort of path dependent as a lot of people sort of presume. It's a really messy thing that there's everything virtually interacts with everything, right? Um, and it should be, right? It's a complex system. There's very few models that I know of, sort of regression techniques, not models, regression techniques that I know of that allow you to have this sort of interactive nature. I think what you can do, and this I used in sort of my engineering days, is come up with some sort of simulation model that predicts all of the different steps that go on, and then have um, a sort of predicted outcome based on that. That's how sort of what you look at to create a refinery, for example. Now, the challenge with that is it's very complicated, and most people discredit those kind of models. They don't want to go into the nitty gritty because there's so many different assumptions. And the other thing, the reason why it's discredited, and there's a good reason for this, is that if it's a multi-step model and multi processes happening, it's very easy to sort of go off kilter when you make a assumption. So let me just kind of explain this. If you can imagine like a decision tree where your first step, you have to decide to do this or to do that thing. Well, then in your next go round, you have to, in the next level, you have to decide, um, you have to decide, so to this thing or that thing, then you have four different combinations. Now imagine at the next level, right? So you got to do this thing or that thing, and then again, this thing or that thing. And now imagine if the outcomes are continuous and you just have this giant mess at the end of it, right? And it's very difficult to sort of predict what things are going to happen. And it's difficult to sort of make sense of that data and to know what you've done is actually right. Now, if you have a very fast computer, you could probably try all these different combinations. That's kind of what machine learning does, like a neural network does, from what I understand. And I'm not by all means not an expert in that particular area, but it looks for the most probable, likely connection between all of these many different steps, um, and sort of comes backwards to find the most probable likelihood step to get there in multiple steps. Now, the challenge with that is that you need extreme amount of computing power, um, and even then, it's very inferior to understanding what the world is because these sort of deep learning models and that sort of bigger models like that, they or bigger techniques like that, you don't really understand the machinery that's going on with it. Um, and all of these have tremendous amounts of complexities that are involved. Um, they're what I'm trying to get at is in order to do science, from what I understand, you need to have a simple explanation and a simple model for other people to believe you. The scientific effort, it's not about modeling the world accurately. I think that that is a poor, somewhat of a misunderstanding of what we try to do, but it's more about coming up with a plausible solution that is very simple and easy to explain. And I think it's not only that, but it's also unique or somehow makes you think differently than what you thought before. And that recipe um, is challenging, right? To come up with something that is unique and different and sort of makes you think differently, um, but also is very simplistic. It really is challenging when you look at real world data. Anybody that will take a deep dive into real world data will quickly get overwhelmed. Even if you have 100 observations, the number of perturbations that you could do with the different combinations of, how you can manipulate those variables is virtually infinite. In those 100 different observations that you have, you could do all sorts of different transformations. You can look for different time series things. Like there's just so much that goes on, and the challenge is not necessarily having access to that data. The challenge is how do you think about it in such a way that you can explain it. Now, I'm struggling with data that I have right now. I thought it was going to be easy, and I thought, hey, um, I've got a series of very exogenous events that happen. I thought, hey, this would be really good. It's like God that comes down and um, shocks the system, right? Um, but to model that, to put that in this sort of regression that I have, uh, doesn't fit within the sort of way that we do regression, right? It doesn't. I can't think of a way to tease this out and to make sense of it, and I'm grappling with it, and it makes me reflect on, and even if you have a brilliant idea, even if um, you have all of the data under the world. This particular data set, I have like over 500,000 observations, so I'm able to do a lot, but I still have these limitations, and part of the limitations are the modeling techniques that we use, the very simplistic modeling techniques that we have, but then also to explain it. And I'm very aware of the complexity that I have to do to explain things, and I struggle with that. I struggle with how to present things in a simplistic way, um, so that other people will believe this, so that not only other people believe it, but it will be there'll be less challenge, I guess, of what I'm trying to do. I don't think that there's an easy solution. I think at this point, I've kind of somewhat given up, and I'm going to go with the best possible solution that I can think of. And even though that it's inferior, it's better than any particular alternative that I have. And I'm kind of throwing up my hands at this moment. And I think that is pretty normal. If you work with regular data, normal data is you'll get to a point that you just work with it so much, you're just like, I don't know what to do, and let's just run with it. Um, and I think that's a normal process with what we all do. All right, take care and have a wonderful day.